Yeah, welcome Rick, and thanks for joining us. Yeah, brome grass. It's we talk a lot about ryegrass around the country, but parts of where you're based and a fair bit of the country is having a growing brome grass problem. Can you firstly just tell us, I mean, you've got some slides on it, but where is it sort of popping up as being a problem, Rick?
Yeah, that's right, Pete. Thanks for the introduction, and great to get the chance to present this through the WeedSmart network. Yeah, we do a lot of work in the low rainfall areas across Victoria and South Australia, and yeah, brome has just become such an increasing issue and of great importance to a lot of growers, not just in these areas where people originally thought brome was a major weed, but it's increasingly being ranked highly in higher rainfall areas as well now. So we saw a real opportunity here. We had a lot of farmers, particularly in low rainfall areas, intensifying their cropping systems still, some not in no-till systems for a long time as yet. They're facing some issues. So we saw a real opportunity for the RIM type approach, the integrated weed management approach, to be applied across to brome. And we've run a lot of workshops with it now, and it's time to present it to a bigger audience.
Yeah, righto. And I won't steal your thunder. I'm sure you're going to tell us a little bit more about that. But I'll just hand over to you, Rick, and let you get on with your presentation. And as we go, I'll interject. And if anyone out there has questions, we'll interject and take them as we go. So over to you, Rick.
Sure, thanks, Pete. So I won't just focus on the tool itself in this talk, and I'm sure Pete will jump in with some questions along the way. I'll present some of our results that we're able to incorporate into a tool like this. First of all, though, I'll mention that this is a collaboration. First of all, it starts with AHRI and the developers of the original RIM model, who made it so easy to actually adapt an extra type of weed into the format. So it's really building on all that work that's been going on for well over a decade now with the original RIM. And Marta Mongiardino here, who's had experience with the original RIM at UWA, and myself, and we've also been able to collaborate with the brome experts across the road here at CSIRO, Gurjit Gill, Sam Kleeman, to bring together the brome model, which has quite a few substantial differences to the original ryegrass model because they are quite different weeds, and I'll run you through some scenarios a little bit later. So it's all about testing profitable management strategies for brome grass. That's what the tool can offer. And as many of you probably know already, it does work very well in a workshop situation. So I'll focus a little bit on that first. But why brome grass? Well, like we were just discussing, it's now, sort of recent work from just a couple of years ago, it's now ranked the #4 weed in Australia in terms of, in this case, just in terms of crop loss or area affected as well. So it is really being listed as a major weed by a lot of farmers covering a lot of Australia, and it probably hasn't received the attention that a lot of other weeds have, and that's mainly because there's still not a huge amount of herbicide resistance affecting brome grass, particularly in the low rainfall areas, but it's becoming a major weed because of some of these other systems changes that are really favouring it, and such as the shift to no-till and seeding practices and such things. So it's way up there in terms of impact on crop, but as we found, when you look at the cost of weeds around Australia, the cost of weeds on crop is, in terms of yield damage, is not the biggest factor by a long way. The biggest cost to farmers is the management and what they spend on keeping weed numbers low, which they generally do a good job of. So RIM or the brome RIM is really about looking at how you might manage those costs as well as keeping the weed numbers at a sustainably low level. So let's just look at some recent results on how farmers are ranking brome as a costly weed. And I guess this caught us by surprise. I mean, ryegrass is still way up there because of the high resistance element involving ryegrass management, herbicide resistance. But brome, #3 nationally when you ask farmers what are the most difficult weeds to control. Obviously not so much in the northern region, but certainly the southern and even the western region, they're figuring very prominently in terms of farmers having difficulty managing this particular weed. And as I said, resistance is not a big factor in that response. It's about just what a difficult weed it can be to control and its competitive nature. So one of the reasons for that is so limited big weapons. So in some areas, you're still able to use clear field technology, Group B herbicides. But you really haven't got too many big weapons against this weed, so it really is a game of many small tools to battle brome over the longer term in an integrated strategy. And often with this weed appearing in low rainfall situations, there is a limited range of tools and options as well in some cases, although that is changing quickly as more break crops or legume crops are introduced. So you do need an integrated strategy, and you do need to play the longer game regarding the seed bank. And when you look at this, it's an ideal situation for applying a tool like RIM. And in many ways, I think brome's actually a weed that's even better suited for applying a systems integrated weed management tool like RIM to look at the economics of control. I thought I'd just throw in a little bit of data here, just because one of the things that we're finding is that it's still increasing as a problem, and that's because the populations, it's not resistance, but it's this shifting emergence pattern and other changes in the populations. This is some excellent data from Sam Kleeman at the University of Adelaide, just with a couple of examples of drastic shifts in populations when you compare fence line examples. And you can see the rapid emergence in this top example of a fence line brome population compared to one that's been in the cropping system for a long time. And it's this factor that's causing many farmers to find brome harder and harder to control. And in the second example here, you can see it's not necessarily causing a rapid increase in emergence late, but it's causing a substantial carryover, in this case of weed seeds, through to a second and third year, which is the other factor that farmers are reporting as an increasingly difficult problem. So it's not just a problem now, but it is because of this evolution and adaptation to no-till farming systems that is increasing. So what we're going to run through is a few scenarios with RIM. Feel free to jump in, Pete, if you want to stop me, but it's about looking at profitable crop brome management systems, putting the range of possible pieces together, and for controlling not only brome itself, but managing these seed banks over time. Testing a range of control options, and many of the control options that have worked well for ryegrass, such as some of the pre-emergent herbicides and some of the harvest weed seed control methods, aren't necessarily as effective on brome. So there's a bit of testing to do at what level of efficacy would make them profitable. In some cases, there's a lot of pressure being put on the clear field technology, particularly here in the Mallee region where we are. And a lot of farmers keen to reduce that resistance risk and also some of the residual issues as well. So a lot of farmers looking to test, can we reduce that reliance on Group B for that range of benefits, and what weed control methods might take its place if we did do that, and what strategies would be profitable in that case.
So Rick, if I can interject, you've alluded to the fact that brome's become a bigger problem because of farming systems changes. Can you be a little more specific about that? So you've mentioned no-till, but is it more continuous cropping, and is it more cereals, or are there particular rotations that you're seeing that are where we're having a much bigger problem? Or can you be a little more specific about where we're seeing the bigger problem?
Yeah, so if you look at the regions that rank brome as their #1 weed, and there's a couple such as the SA Mallee, Big Mallee, and some other lower rainfall areas. So there's a few that do rank brome as their #1 weed, and probably have for some time. But these areas have often come out of a very cereal intensive system. There's been a shift to no-till involving intensive cereals initially, and what we are seeing is a change in the farming system in these low rainfall areas. There's been a dramatic increase in break crops, legume crops in particular, in the last just 2 or 3 years as better varieties become available. And that's not just because of the better varieties and some of the good prices recently. A lot of that early shift was because of brome, looking at a bit more diversification. So that shift to intensive no-till with a stubble reliance has favoured brome populations, and that selection of those populations that will cause trouble, late emerging weeds. So it's that shift that led to this issue, and now farmers are responding with shifts to their farming system. But yeah, the initial factor really was that no-till in cereal intensive systems.
So do you think it's the lack of cultivation or just the more intense amount of cropping in the system?
Well, I think what we're also seeing is the later emerging weeds. So and in the case of brome, of course, you've got less late selective options in cereals. So that's a big factor as well. So you've got seeding systems with stubble retention that are perhaps favouring later emergence, and then you haven't got these late season options, and that's led to some pretty high seed banks that farmers are managing over 3 to 4 years.
Yeah, righto. Thanks, Rick. Yeah, and anyone else out there, if you have questions as we go, make sure you type them into the questions box, and we'll keep pausing for questions. So, yeah, keep going, Rick. All good.
All right, we'll carry on. So I just thought I'd quickly mention RIM. Now, many of you have probably experienced a RIM workshop, helping you put the pieces together. And there's also been plenty of research done using this tool. And one of the big features of RIM is that it is easy to use in a workshop situation. So it's not necessarily the most comprehensive tool out there, but particularly with the work that Mathilde Lacoste and AHRI's done recently, it's become a very highly usable, highly adaptable tool, and many people have benefited from it. So we've been able to build on that with this Brome version. And to me at least, the big potential for a tool like RIM is that it's easy to use in a workshop situation. And if I can just indulge a little by going back quite a few years, it has actually had a demonstrated impact on farmer adoption behaviour. So sitting through these workshops, learning about the economics when you consider the longer term seed bank effects and the longer term economics of things that aren't necessarily that obvious in the field, such as extra crop competition and through higher seeding rates, for example, and some of the seed control methods. It has actually been shown returning to farmers a year later versus who were at the workshop versus those who weren't at one of these workshops. It has shown that it did have a significant effect a year later on adoption and adoption behaviour in terms of planned adoption of different practices. So it's got a reasonable track record. The challenge, of course, is there's only so many people you can deal with in this workshop situation. And one of the things that makes it attractive to consultants, and several consultants like Michael Moody, who's in one of the photos there on the left, is that it is easy to set up. And we know from some of our work that you're not going to get very far with a decision support tool or a workshop tool if it takes more than 3 hours to set up. RIM takes about 30 minutes in these workshop situations to really get it up and adapt it to a local farmer audience. And that's critical for having an appealing and useful tool. And we know that advisors and farmers, that they value that ease of getting to the core questions quickly, more so than actually the highly accurate results. So you're better off making it adaptable than focusing too much on that perfect prediction. So Brome RIM. Marta Mongiardino has done a lot of work pulling together the data for Brome RIM, and it'll be available in the next week or two, very much based on the same format. And I'll skip through to this slide here, which is really the core of RIM. It's where you're able to set up the strategies, and this is a very basic crop rotation. It's actually a real one from some farmers where we did some validation checks. And this is almost an old-fashioned rotation here with no pulses in it for the Mallee region where this was set. But you can see year by year, you're able to focus on setting up each year as it goes with a starting brome level to control, reasonably high in this case. That's why you're getting blowouts here at year one. And setting up the rotation with a range of different times of sowing. This is only slightly delayed by a week after the break. There's other dry seeding options as well. You're able to choose from a range of knockdown options, including any options that you put in yourself. In this case, it's just a very simple one, including trifluoralin right through, but with several new pre-emergent options now, you can include the range of pre-emergent options that you might choose to use. And we've got a reasonable idea of their efficacy now on brome. Here we just assume no till all the way through, but there's a range of tillage or seeding systems as well. and crop density, plus some pre-emergent, and you can adapt this tool very simply to include the whole range of pre-emergent or post-emergent options that you might want to include. The big feature here, and what people really like to focus on, is this average gross margin figure. So that's the average over this 10-year period, in this case $134, based on some assumptions we've made about the price, crop price. And so you're focusing on this profit figure, but you can also see tracking the brome grass seed numbers over time, or plant numbers in this case. And you can see how much it varies given the different treatment options we've got here. It's set up nicely to look at what this means in terms of weed control expenses, particularly in the low rainfall regions where we do a lot of work with Brome RIM. Keeping those weed control expenses low is a priority, as with all expenses. But you can also see the profit or the income factor here. So that's the core. And just as a very simple example of the validation, it's not an easy tool to validate because RIM doesn't include seasonal variation. So you can't expect it to represent a single season perfectly. So over a longer time, though, you can see for the eight years that we're tracking here, so this is the sort of validation exercise we've been trying to capture. There's obviously some seasonal effects in reality from this actual farmer's paddock that have affected things that RIM in this case hasn't detected, but that's the sort of validation data that we've attempted to use against this tool. So let's look at a scenario. First of all, this just gives you some idea. I thought I should show you some of the options of how you might analyze the impact of the treatments that you're looking at over time. So there's a whole range of ways to look at this. This is tracking seed bank over time, brome grass seed bank over time, as well as looking at profit. And it gives you a nice chance to look at side-by-side examples if you're testing different scenarios. So let's look at a couple of options here, unless you wanted to stop me here, Pete.
I have had a couple of questions actually, so I might just pause for them briefly. One, I think I know the answer to this. Is there any plans for a RIM app? And the person asking the question said it would be cool. But I think when we looked into it, it was very expensive, and no, we weren't planning on going down the path of making it an app. Have you looked into it at all, Rick?
Well, we've certainly looked at converting Excel-based programs like RIM into an app, and yes, it is very expensive. We also did a study just a few years ago on what format people would like a tool like this in. Things change quickly in 4 years, but back then Excel, which is what RIM is, even though when you look at it, you won't see a lot of Excel visible to you. It is an Excel-based program. People still did prefer that downloadable version for a tool like RIM, but it's possible that's probably changing quickly, but it is a costly exercise to shift it across.
Yeah.
And
we
it's
also
had
it. Go on.
Yeah, it's also a matter of screen size as well. There's a lot of potential detail here that you can look at. So it is a good tool for the larger screen.
We also had a chat with AgWorld about having RIM built into AgWorld, so it could actually track, pick up, your inputs from your AgWorld, and then put that directly into RIM, and then be running RIM live in the background, sort of thing. But that too is going to literally cost hundreds of thousands of dollars, and so it's on the back burner at the moment. But it's all possible. It just depends whether people want it and whether we can get the funding, I guess. And the other question is it parameterized for different regions in Australia? And further to that, I was wondering, with the percentage control of brome, with the different herbicides and so on, have you guys put those in there, or does the user have to set up their own, control percents and so on? Yeah,
that's a really good question. So, just like the original ryegrass RIM, the idea is that there really is just one version for Australia. But what AHRI's done initially with RIM is made it a lot easier to change almost all of the parameters that you need to change. So it's opened up a lot of options. Now, in a workshop situation or working with you with a farmer client, for example, you probably wouldn't go right to the back. You might do that initially yourself, or you'd just be happy to use it as it is. But there's a lot of things you can change in the background to adapt it to your local situation. The first things you change is when you go through and you can quickly change the efficacy of some practices, your local yields, your local prices, and the efficacy of certain practices that may or may not work as well in your local context, or how you might use them particularly on your farm, for example. So there's a lot of scope there to adapt it reasonably quickly and simply, which is a really good feature of it. And the same applies to the new Brome RIM. So the intention is that there will just be the one Brome RIM, but it will be in quite an adaptable format. What isn't so easy to adapt is the fact that populations do differ. Just like I showed in that data of Sam Kleeman earlier, populations do differ in terms of their emergence pattern and different profiles of the genetics of the population in terms of emergence, hard-seededness, dormancy, things like that. That's not an easy thing to capture because you don't really know your own population. So there is basically an average type population in there. It is possible to change that, but it's not an easy one to know how to change that. So that is an opportunity to adapt to different populations, but it's not something you'd normally use when you're not using BRIM in the normal way. In terms of herbicide setup, yeah, it really is set up for that to be done very quickly and easily at the start, and not just change the efficacy of what's in there, but also to add new options. So it's a really strong feature of the new RIM setup that you're able to add new options very carefully, because there's a whole range of different mixes and things like that that people might want to include with their own prices.
Have you put in some herbicide efficacy, typical efficacy for the products already, or do people have to do all of that themselves?
No, we'll be included in the launch version in a week or so's time. We'll be including some starting figures using the basic herbicides that we think people might most commonly use, for example, and the efficacies. But you'd encourage people to actually look at those and perhaps adjust them according to how they use them, the timing, different rates that they might use for some of the pre-emergent, and things like crop topping, the timing of things like that, and how you might choose to use it. So we'll be including, it won't be coming empty, it'll be there ready to run for common scenarios, but it is designed to encourage people to adapt it quickly.
One last question about parameters, and then we'll get back into it. From me is, have you changed the crop competition effect on brome compared to ryegrass? And probably comes back to a bit of personal experience. I've really noticed that brome hates competition, and when we've done competition trials, brome seems to suffer a bit more than ryegrass, I would say, in seed set. Is that what you've seen, and have you changed that parameter?
Yeah, so that certainly has changed. Now, brome generally is a competitive weed. One brome plant versus wheat compared to, say, one ryegrass plant versus wheat. So brome has been set up as a more competitive weed than ryegrass, and that's what the common figures would show. But at the same time, crop competition has an enormous effect on seed set. So that is built in there. I'd have to look a little bit more into the detail of how that plays out, just to check the seed set results from different levels of competition. But one thing you certainly see when you're using Brome RIM is that crop competition is one of the most important tools that you have, and it's one of the messages I think that people take away from the workshops when you use Brome RIM, is that just the importance. And I think one of the reasons for that is that brome is a problem weed on a lot of sandy soils where establishment can be an issue, whether it's non-wetting or with other issues. So yeah, poor crop establishment can be common on areas where there's plenty of potential for brome to get away, and that's one of the big challenges that farmers like to test here. What do you do with those real difficult areas when you've had a blowout? How do you respond? And what effect would better crop competition or emergence have?
Yeah. All right, I'll be quiet for a while now, Rick, and let you get back on with it. But yeah, thanks for that. And yeah, keep the questions coming in, everyone.
All right, well, I'm just going to run through one very simple example. I don't want to fill the webinar or the screen with lots of numbers and charts. So it's, first of all, this is just a simple indication of just one of the pages where you can modify things. And, you can modify your seeding rate, which relates pretty directly to crop emergence. There's a range of factors here you can adjust to affect the break crops and such things. Crop damage, so we've actually got quite high crop topping yield penalties here because we're looking at that trade-off between crop topping yield damage and efficacy against brome, which is often quite low given the timing of brome, which dropped its seed generally earlier than ryegrass. And a range of practices here. And you can see down here, 60% figure is probably a bit high for whole paddock burning, but you can see here we've assumed initially, in this case, quite low efficacies for harvest weed seed control for brome because of that factor of the potential for a lot of seed to be shed. So that's just a few of things you can adapt, and they're not all, we won't feature all of them right now. So let's just look at this simple scenario. It's the same one I showed before in that validation exercise, but what I have done is just add in a couple of narrow windrow burning, and narrow windrow burning is rapidly being adopted in the Mallee regions here, and brome is a major target for that, even though farmers know it can be difficult to capture a large proportion of the brome seed in the harvest process. So this is just an example here where you can add narrow windrow burning in a few situations, a few years. You can see here that there's still a pretty high weed seed bank after various years, particularly this year after not applying narrow windrow burning in barley, for example, where you may have chosen not to do that for the risk of it being a little bit difficult to manage in a heavy barley stubble. So you can see it tracking the seed bank here, and also tracking the mature brome plants at the end of the year. And we're up to around $137 on average in this pretty basic rotation with a reasonable reliance on, I've called them group Bs, but IMI herbicides in clearfield options, which in this farmer's case are still viable. So that's the sort of baseline scenario, adding in some narrow windrow burning. So that's not really good enough weed control. So a farmer would want to be looking for other options here, I think. So first of all, this is, as you well know, this is a range of harvest weed seed control options that farmers are very keen to consider in our region, but often unsure about just how the efficacy might be against brome. But we are getting a lot of farmers very positive about the results they're getting, and even results around 50% control being very valuable to farmers. But this is a chance to test in a model like RIM whether it's worth the investment in some of these tools. And in the case of narrow windrow burning, of course, it's not a large investment. I'll just throw in these results, just some of the results that inform what figures we put in. This is some excellent work by Michael Moody and Mallee Sustainable Farming with others, just looking at the importance of early harvesting on brome control. Now, this is a much more dramatic fall away in the potential to capture brome seed in the harvest process than what you might see for some other weeds because of its early shedding nature. But there is the potential to capture 60%. And we're seeing farmers find a few novel ways to boost this further through use of different pre-emergent herbicides, which means you might only have later emerging brome plants as well. But this is some pretty common figures that I think farmers see line up pretty well. And it all depends on that harvest time as to what figure you might use or assume. We've in that initial scenario, I just elected to use the lower version, around 30%. But in the next scenario, we'll go a little bit higher. Now, I'm going to take the opportunity to mention some of this work we've been doing. We work a lot on non-wetting sands in some of our work with brome here, and we've found some quite remarkable results with on-row seeding, and it's all a lot to do with crop competition. So this is what you often find in our crops. You see this big crop of brome coming up in last year's furrow on these non-wetting sands because it's a perfect environment for brome to emerge from, wetter, protected, seeds often falling in there. So it's quite common if you left it uncontrolled to see that that pattern with a lot of brome coming up between last year's crop row if you were seeding your crop into row. But we've, like at some of the work the Department of Ag in WA looked at on-row seeding, and there's an obvious reason why on-row seeding is leading to better crop competition, and that's just the main reason shown by the blue dye there with the great pattern of wetting up under the last year's row. And by exploiting that, we've shown quite remarkable brome weed suppression results. So this is an example if you're seeding on last year's row or near last year's row, ideally, not necessarily right on last year's plants. And that's sort of what some farmers are trying to do on these non-wetting sands. We're not suggesting this for other types of soils, but certainly on non-wetting sands, we've seen some big results. So it's a couple of years in a row, we've had more than 70% seed set reduction when you've sown the crop on last year's row because of that better establishment, but also better competition as well. So that's happened 2014, 2015. 2016, because it was so wet and long, the late brome was able to carry through to set seed, so we didn't see that such a big difference. But these are some quite big figures, and we're seeing some big differences this year as well. And we're also, in terms of crop competition, Pete, we're also, this year alone, we're seeing some big differences in crop biomass from this on-row seeding and equivalent differences in brome biomass differences as well due to suppression, but also less plants. So you can see here, with or without pre-em, you're seeing these big differences between on-row seeding in the light blue and inter-row seeding showing much less crop biomass, so therefore much less crop competition. So this is something we're really looking at, but the challenge, of course, is how you might manage that inter-row or near-row seeding across multiple soil types. So that's something I've thrown in. So there's something you could represent in the brome version. So I've increased the crop competition in this case to reflect higher crop emergence. And what I've also done here, and you can see down the bottom here, I've lifted the efficacy from 30% for narrow windrow burning up to 60%, which many farmers are claiming they can achieve, despite some of the challenges of brome. So when you do that, you can start to look at, and normally you do this step by step, so you can see the individual differences. But if you look at the scenario now, with what you can see is that the profit here is increased by about $10 a hectare on average. You can see it's a much better profile in terms of maintaining the low seed bank, which does give mallee farmers in particular the flexibility to respond to different opportunities, such as growing pulse crops and other options where it might be a little bit harder to control brome in some cases. So this has led to much lower weed levels through here, an increase in profit. But when you do look at this scenario here, there's an obvious thing to do right now, and that's to knock this population back with some sort of heavy treatment in the first year, which I won't do now, but you'll see an obvious profit opportunity by doing that in this case. So it's just an example here, Pete, of how you can test a couple of brome options for brome and in a sort of typical farmer situation. One of the good things about RIM itself is how you can compare things side by side pretty easily. So these are the two options side by side. And at that lower option, there's still some work to do, but you can see it's maintaining a much lower seed bank over the 10-year period, and it's increased the profitability. And there's a couple of years, you can see in the blue here, a couple of years here where you're able to drop that weed control expense down substantially.
Just a bit further to that discussion, Rick, another question's come through about bringing in swathing. Any thoughts on, you got up to 60% brome removal with harvest weed seed control for early harvest. Any thoughts about swathing increasing that further, do you think? Yeah,
and I was surprised. In the last couple of workshops we've run, there are certainly farmers making good value from getting good value from swathing, or it's also hay production as well. And it seems we haven't done the work on this, but I think it really points to the opportunity for some winning combinations of practices here that can come together to boost the efficacy. So with the right establishment, perhaps investing that little bit more in herbicides. I've only included trifluralin in this example as a pre-emergent herbicide, but with CSIRO and maybe some other options, you can get a little bit longer control of brome, meaning later weeds, meaning that swathing does give you that opportunity for better control. And that's something we're keen to look at, what these sort of combinations of different practices that might boost some of these things. Because on their own, you might wonder whether 40, 50% good enough. Often it will be. But if you can get those up to 60 or 70% by combining a couple of these practices, so that something like swathing is capturing more of the, or killing more of the weed brome population, then it becomes a winner. And
I guess the other thing that always springs to mind for me is the challenge. It's a bit of a challenge in the low rainfall zone, but if we've got these late emerging weeds, particularly brome grass, crop competition becomes very important, because if they're late emerging and then they come up and they're in a competitive crop, the crop has well and truly the upper hand. So trying to exploit that shift in emergence, and so with crop competition, swathing and harvest weed seed control, they do all go together very well.
Yeah, that's right. And that's why we're keen to, well, we are doing a lot of work on sort of managing these sands and just how you might improve crop establishment and early vigor, because you're right. If you're able to get only be dealing with the late emerging weeds and then that strong crop competition later, then that is the winning combination for suppressing seed production. And that's why we're seeing such big figures there in some of those results. You can make a big difference. 70% seed set reduction is a big gain, and that's largely through crop competition, and it is possible, but it needs a few things to go right to allow you to get that. And it's those combinations that I think deserve a lot of attention.
Yeah, it does. With all of these things, it's much easier doing it on a spreadsheet than it is in real life, isn't it? But the spreadsheet does allow you to test some theories that you might have, and then before you put them into practice.
Yeah, and they're not just theories. Often there are people considering some pretty big investments in some of the harvest weed seed control methods, for example. And also even some of the pre-emergent herbicides, which some of those packages are could be $50 plus, which is a lot in a low rainfall farming system. And this lets you see whether that taking your efficacy for pre-ems up to the 70-80% level from 40 or 50 is a good investment over time.
Absolutely. And yeah, if you're thinking about buying a Harrington seed destructor, for example, the cost of the destructor goes in and is amortized over the 10 years, I think, isn't it? So you do get to see whether it is worthwhile spending that money.
Yeah, that's right. So this tool, RIM, initially was developed by not just weed scientists, but economists as well. So it has got quite sound economics of how you might factor in the cost of some of those capital costs. Carry on here, Pete.
Go for it. Yep, I'll let you run to the flag.
I haven't got much more to go. So I showed this comparison. So just like Pete and I were saying, you can show a lot of these options side by side, which is a feature that a lot of farmers like to play with. So just to finish off, I didn't think I'll probably push the barrow hard enough myself, but these are some quotes just from a recent workshop we ran, just from one of the workshops. And it's always interesting to see what people take away from a tool like this. So after these workshop situations where you run through a few of these scenarios and people get to play with their own questions of interest or scenarios, what would you change after investigating this? So these are people who are probably considering changes anyway. So harvest weed seed capture, the ability to weigh up whether those levels of control do pay off over the longer term. Better planning, thinking ahead in terms of these combinations, for example. Also crop rotations. I didn't feature it in our example I just ran through, but often it's crop rotations, introducing some of these crops, even if it's a brown manure or some of the other legume options that are relatively new in some of these areas. what benefit that can have. For people dealing with resistance or concerned about reducing their selection pressure, managing herbicide use patterns, windrow burning often is something that's investigated, and as well as a whole range of the non-chemical controls. So a lot of people do go away thinking that they've learned a little bit more about whether these things are worthwhile on their farm. And it pretty well sums up the use of this tool, although it is also used in research. Farmers like to use the program to look at a range of different options before making a decision of which to take on, and sort of collecting a range of ideas on how you might manage a tricky weed like brome, particularly as their cropping system is becoming more complex with a whole range of new options available. So some people just using the tool for planning rotations and crop types that they might use into the future. So that just gives you some idea of how people are using it. I should also mention the bit more on the research use. There is a version, because Brome RIM itself, as in RIM, like I said, doesn't include any seasonal variation, which, as you said, Pete, using a spreadsheet's easy. Farming's a lot easier too when it's the same season every year. So it is kept simple, which makes it usable. But there is a research tool called LUSO, developed between UWA and CSIRO, that does include that seasonal variation, but that's a little bit more, needs a little bit more input to use, because you're including a range of different season types, but it's an important tool as well. So just to finish off, the last slide, we'll be making this tool available alongside the ryegrass RIM through the good folk at AHRI, so that people can find Brome RIM sitting there on the AHRI website. And so acknowledgements to Marta Mongiardino and Gurjeet and Sam for all the work that they've contributed to this tool, but also the AHRI team, including Mertil, and also Michael Moody at MSF and John Kierkegaard, who are involved with the project, the GRDC funded project that led to this new tool. That's all I've got, Pete. I was going to leave it there unless there's more questions.
Thanks very much, Rick. Yes, and if you do have questions out there, get them in now before we finish up. For me, I think what these programs do, like RIM and others, is it puts a whole heap of research that's gone on for years and hundreds of trials all in one spot. So almost rather than having to look up every individual research trial, you can really go to the computer model and put in some scenarios, and it gives you the answer based on all that research. So not only is it this good predictive, or not predictive, but tool that analyzes a range of farming systems and gives economics, it's got a wealth of research data in behind it. I think that's a real strength.
Yeah, and it also, so it's got that scientific data built into the tool, or at least a summary of it, averages of it. But then it also includes the ability for local farmer and advisor knowledge to be included on top of that, with just the local practices as well. So it's that combination, I think, that really helps with the engagement and practicality of the tool. It's interesting that one of the most common responses from farmers is it's a very easy to use and practical tool. I mean, it's a spreadsheet, so it's not necessarily practical, but it is designed to be easy to represent your farming system.
Look, I think it's excellent. And for example, like what you did there is you changed harvest weed seed control from 30% to 60%, and then immediately could see the difference that has on the whole 10-year rotation. And so then we can go, okay, how do we get harvest weed seed control from 30 to 60%? And it helps us ask questions of ourselves. You know, it makes us realise that it's an important thing to do, and then helps us ask ourselves practical questions of how can we actually do that in practice. So I think these tools are wonderful, and yeah, we'll give it a good push and hopefully get it out there, and it is useful for growers to help make some of those decisions before having to make the investment in real life on farm.
Yeah,
right. Thanks very much for your time, Rick. We appreciate that you've got to give up time and put a lot of effort into making a presentation for something like this. It does take a lot of time and effort, so we really appreciate your time today.